Section 4.1 is on page 260. Let's just say page. It talks about quadratic functions and models. A general form of a quadratic equation is ax squared plus bx plus c equals 0, in which a, b, and c are real numbers and a does not equal to 0. If I want to write this in standard form, a is the only value that remains between the general and the standard. And if I could write the parabola this way, then I could figure out that the vertex, which is the most crucial point of a parabola, is the opposite of h and k. Now, to get from this form to this form, I need to complete the square. Or, if you know what the vertex is, you could copy from this to this, copy a in, and just write it in the form provided you know what h and k is, and I'm going to show you how to find that as well. I'm going to take those off so that it doesn't clutter the graph. Alright, now I'm going to start with first set of problems. First set of problems, it says identify each parabola's vertex and axis of symmetry, then state whether the vertex is a maximum or a minimum. A graph is not needed, but I would like to really just a rough sketch, not an actual graph. We know here that the vertex is the opposite of this, that's negative 10, and since there's nothing there, it's kind of like plus 0. So if I really look at a quick sketch, again, no need, the graph is not needed for this, but that helps you visualize. If I move negative 10, assume that's negative 10 right there, 0. Now, if this number is positive, then the graph opens up. Since this is negative, a rough sketch looks like this. So the axis of symmetry actually is right there. The vertex gives you everything that you need. So it says identify the vertex, we just did. Axis of symmetry, well, axis is always, if it's opening up and down, it's always x equal, and it's always in the vertex. That's the axis of symmetry. And is it a maximum or a minimum? If I look at this graph left to right, if I'm moving left to right, you'll notice that this point right here is a maximum. So max will do. That takes care of it. If I look at number 6, the vertex is also the opposite of this, which is 3 and a 1. And the axis of symmetry is really the x value, because if you look at this parabola, assume that you move 3 to the right, let's say that's 3 units, 1 up, let's say that's 1. This parabola, since this value is positive, this parabola opens up. And that makes that point, again, from left to right. If you read this, you'll notice that that point right there is a minimum. Min will do. Again, a rough sketch, not a graph. If I look at this third problem or example, number 8, I notice that the vertex is the opposite of this, which is negative 4 and negative 3, which means I'm going to move negative 2, negative 4, and negative 1, negative 2, negative 3. And since this value is negative, this parabola opens down. Again, the axis of symmetry is really the line in which the right half and the left half of the graph are identical. The axis is x equal, again, it's always in the vertex, negative 4. And we know that this is a maximum. Now, given ax squared plus bx plus c equals 0, if I wanted to figure out what the vertex is, I would have to complete the square, meaning I need that to be a positive 1. I would divide by that a, and that would be x squared plus b over ax. And to complete the square, as you know, we need to add a number to both sides of the equation, and the number would be half of this. If I take half of b over 2, or b over a, that's b over 2a, and I square it. I'll add b squared over 4a squared to both sides of the equation. That's pretty much how we derive the quadratic formula. We're guaranteed that this becomes an x with that sign. The number before I squared it, and the number before I squared it was b over 2a squared. And here I will get a common denominator, which is 4a squared. Multiply this by 4a top and bottom, and that becomes b squared minus 4ac. And if you really think about it, I could solve now and get the quadratic formula. That's not the purpose of this problem. The purpose of this problem is really getting the equation in standard form. And you notice the vertex is the opposite of this. And that mess, it's easier to say just find the y value once you find it, because this is a lot to memorize. So if I really wanted to summarize what I did, given ax squared plus bx plus c, or given f of x equal, I could say, well, I can know what the x value of the vertex is. That's negative b over 2a. That would be number 10 in the first problem, number 3 in the second problem, and negative 4 in the third problem. And if I substitute that in and figure out what that value is, that would be the y value, and that's how I can find the vertex. So either you complete the square to go from the general form to the standard form, or you memorize the vertex is really negative b over 2a of the general form. And remember that you're going to copy what a is once you know the vertex. So if I look at the next set of problems, it says identify the vertex of each parabola by writing the equation in standard form of the quadratic function. I am going to complete the square on one of them and show you how this works. You could say f of x equals x squared minus 22x, and move the 116 to the left. And you could add a number to both sides of the equation. And you could say f of x minus 116, take half of the middle number, which is 11, and square it, that's 121. And this right side becomes a perfect squared. X with that sign, the number before I squared it. And if I really add those, that is a 5. And I could say f of x equal x minus 11 squared minus 5. And if I get it in this form, I could say easily the vertex is 11, negative 5. And notice the number in front of the square remained the same. Or I could say, you know what, let me find the vertex by figuring out what is negative b over 2a from the original. That is minus b is 22 over 2 times, and a is a 1, and that would be negative 11, and there it is. I'm sorry, minus a negative 11, that's positive 11. And once I know that to be 11, I could plug it in and figure out what the y value is. That is, I could say f of 11 is actually 121 minus 22 times 11, 242 plus 116, and this turns out to be 137 minus 242, which is a negative 5. So you notice that this is a lot quicker to find than the alternative, u completing the square. And once I know what that vertex is, I should be able to go back and put it in that form. So I'm going to try that on the next problem. So on this problem right here, I know the vertex is negative b over 2a, and evaluating the function at that. I don't like that 2a. So if I take negative b over 2 times 1, because that's what a is, that is negative 3. So if I know the vertex consists of a negative 3 for the x, and for the y, I'll just find g of negative 3. That is 9 minus 18 plus 8. That is, what is that? 7. That's a negative 1. So if I know what the vertex is, I found it. I can write g of x as, copy that number down, a 1 in this case. You don't have to write the 1, I'm just putting that for your notes, x. And remember, the opposite of this, minus 1. And there it is. And if I do that on the third problem, here I will say, well, let's see, what's negative b over 2a minus a negative 40 divided by 2 times, and a is a negative 2 in this case. 3 negatives will yield a negative. 40 divided by 4 is a 10. I just figured out the vertex has an x-coordinate of negative 10, and now I could go ahead and say g of negative 10, that will be the y value of the vertex, negative 2 times 100 plus 400 minus 193, that would be negative 200, 393. If I add those plus 400, that turns out to be a 7. So if I know the vertex is 7, I could write g of x as, again, we're going to copy this value down, and that's going to be a negative 2, x, the opposite of that, plus 7. And there's the standard form of a parabola. It helps a lot to really get it in this form for graphing, for figuring out the axis of symmetry is always the x-coordinate. The x-coordinate of the vertex, and I could figure out this is a minimum, this is a maximum, and this is positive, a maximum because it opens up. I'm sorry, this is a maximum, minimum, and a minimum. And we have 2 more to go. If I look at number 20, the same deal. I say, well, let's go for negative b minus, let me write that down, negative b over 2a is minus a negative 24 divided by 2 times, and a is negative 3 in this case. 3 negatives will yield a negative. That's going to be 6. 24 divided by 6 is 6. So I know the vertex has an x-coordinate of negative 6. Now, I will figure out g of negative 6, the y value, negative 3 times 36, plus, what's 24 times 6? That is 24, 12, 14, 144 minus 49. G of negative 6 will be, if I multiply that out, that is 18, 108, plus 140, well, 144 minus 49, that would be a negative 157 plus 144, and what would that be? A negative 13. So I know this is negative 13, and that means I could take this and write it as g of x equal, again, I copy down, we call it the a. That's crucial to figure out whether the parabola opens up or down, squared. So that's going to be x, the opposite of that, plus 6 minus 13. And if I look at number 22, I notice that, you know what, it's already in that form. I already know the vertex is. If you write it this way, that's like saying, you don't have to do this, I'm just showing you that. That's like x minus 0 squared minus 3, which means the vertex is 0, negative 3. And there it is. Now you should practice graphing those. Graphing is not that big of a sketch, a quick sketch, you know, meaning I could pretty much get a quick sketch for each of those. Move 6 to the left, 1, 2, 3, 4, 5, 6. Let's say that's 3, 6, 9, 12, 13 is about right there. And this parabola opens down. That kind of gives you a good idea of what the graph looks like. Here they say sketch a graph. If we want to graph this, we could figure out where does this equal 0 at 0. So there's the center. And this opens down. So I could just sketch a rough sketch like that. That'll do it. I could pick points, you know. I could be more specific and say, look, if you picked a point above and a point below, a 1 in there will give you negative 4/5, and a negative 1 will give you negative 4/5. So go 1, negative 4/5 is about right there, negative 1, and this will be an official graph by labeling those points. When I get to number 36, again, it's not as easy in this case because I don't know where the vertex is, but I could find that. I could say the vertex is negative b minus a negative 8 over 2 times negative 2. That would be 3 negatives, a negative. 8 divided by 4 is 2, there it is. And g of negative 2 will be negative 2 times 4 plus 16 minus 9. That would be negative 8 minus 17 plus 16, that's a negative 1. So once I write this in standard form, everything works out smoothly. There's a negative 2x, the opposite of that, minus 1 squared. That's the general form. To sketch a graph, I could say, well, the vertex is at, oops, I didn't center that, let me center it properly. The vertex is at 2 to the right, 1, 2, negative 1 right there. And I know this parabola opens down. I could pick some values really quick. X equal 2. So you put a 2 in there, you get negative 1, which is the vertex. If you go a point above it and a point below it, a point below it and a point above it, if you put a 1 in there, you get 1, negative 1 squared, which is 1, negative 2, negative 3. And if you put a 3 in there, 3 minus 2 is 1 squared, that's 1, that's also negative 3. So I could say 1, negative 1, negative 2, negative 3, and 3, negative 1, negative 2, negative 3, and there is an official graph. Now, suppose I want to figure out an equation of a circle. It says of a parabola. Write the general form equation of each parabola that passes through the given point and has the given vertex. The vertex is crucial. I know that f of x equal a, we don't know what a is yet, x minus 4 squared, the opposite of that, minus 8. Since this point is on the graph, then that's an x and that's a y that should satisfy. So that's how I'm going to figure out what a is. Negative 9 equal a into, instead of x, I'm going to throw in the 2 squared minus 8, and there it is. That's negative 9 equal, this is a negative 2 squared, that is 2 times a, that's 4a minus 8. Add 8 to both sides, and a is negative 1/4. Once I know that, then I could really come in and say this parabola has a leading coefficient of negative 1/4, x minus 4 squared minus 8. Same deal with number 40. There's the vertex. That means f of x, or g of x, whatever you want to call it, a into x minus 2, the opposite of that, squared, plus 2. And I could use that point, replace x by a 3, replace the y by a 5, and I could figure out what a is. That says 5 equal, this is 1, a plus 2. So subtract 2 from both sides, there's a, and I could say for this parabola f of x equals 3 into x minus 2 squared plus 2. Oops. Okay, and you'll notice everything they ask about in a parabola could be solved by you finding the vertex. That's the key. Okay. Find the maximum or minimum value. Well, the same deal happens. I look at this, say, okay, well, what's the vertex? The vertex consists of negative b, negative 1 over 2 times a, negative 3. That is positive 1 over 6. And if I figure out g of 1 over 6, that is negative 3 times 1 over 36 plus 1 over 6 plus 9. That is negative 1 over 12 plus 1 over 6 plus 9. If I put everything over 12, which is the LCD, multiply this by 2 top and bottom, and multiply this by 12 top and bottom, 12 times 9, that is 18, 108, and that turns out to be all over 12, 108, 110, 109. That is 109 over 12, if I didn't make a mistake. And when they say find the maximum or minimum value, we would say here that the maximum or minimum, well, what do you think that is? Since this parabola opens down, right? The parabola looks something, a vertex of 1, 6, 109. Since this opened down, that is a maximum. We have a max of, and it's always the y value, 109 divided by 12. So anything you need in a parabola is really given in the vertex. And if I take this last example down and I do the same thing, say, well, let's see, what's negative b over 2a? Negative 2, that's b, over 2 times a is a negative 2. That will be a positive 1/2. So that's the x-coordinate of the vertex. To figure out the y, which is the maximum or minimum, you figure out what is f of 1/2. That is negative 2 times 1/4 plus 2 times 1/2 plus 6. That is negative 1/2 plus 1 plus 6. That is negative 1/2 plus 7 all over 2, negative 1 plus 14. That is 13 over 2. So since this is kind of the vertex, half to the right, 13 halves up, 7.5. Since this opens down, that would be again a maximum of, and it's the y value, 13 halves or 7.5. And there's your homework on this section, and that concludes it.